Hi, I'm John Courtney and welcome to installing and configuring DNS services on Windows Server 2016. Over this course we'll be going over how to install DNS from scratch using the Server Manager utility. Then we'll move on to DNS zones and records, followed by an explanation of the inner workings of DNS, such as setting up scavenging, and then finally it's onto some useful tips on how to secure your server against threats such as unauthorized zone transfers. To complete this course, ideally you should have administrative level access to a test server or virtual machine running Windows Server 2016, as this will allow you to follow the practical steps as we go through them during the lectures, and give you the best understanding of DNS and how it works. It should be noted here that I would highly advise testing any changes, including practice for this course, on a test environment rather than your organisation's production DNS servers, as changes made can have widespread impact on your organisation, especially if completed incorrectly. Also, although this course is aimed at Windows Server 2016, most of the concepts here are also applicable to earlier versions and also future versions, such as Windows Server 2019, which, although released in October 2018, is not yet widely used in corporate environments due to most of them waiting for the first service pack to be released. This is most likely to be in the next year or two. Now that we've gone over the course outline, let's move on to the first lecture, DNS and NS Lookup. DNS stands for Domain Name System and is essentially the computer equivalent of a phone book, translating the unique identification number, known as an IP address, of your computer into a human-readable format. This is known as a domain name. For example, you might type in worldwideweb.google.com instead of its IP address. In this example, google.com is the domain and World Wide Web is a subdomain. It's possible to have more than one subdomain as long as the total number of characters doesn't exceed 255. Let's have a look at the NS Lookup utility, which is built into Windows. To access this utility, press the Windows key and X keys on your keyboard at the same time. When the menu appears, click on Command Prompt. When the Command Prompt window appears, type NS Lookup and then press Enter. You'll then see the default DNS server along with its IP address. This will usually be issued automatically by the DHCP server which you are connected to. DHCP being a service that automatically issues IP addresses, DNS server addresses, and one or more default gateways to client PCs. NS Lookup is typically used to obtain the IP address or addresses tied to a specific domain name, but it can also be used the other way around. As well as A records, explained in more detail later on, the utility can also be used to obtain information such as MX records and various other record types. For example, if we type worldwideweb.google.co.uk, it will come back with its IP address, which in this case is 216.58.211.35. Notice here that because we're running a modern version of Windows Server, the IPv6 address is also displayed. IPv6 is not widely used at this time and so is beyond the scope of this course. Now, if we type in 216.58.211.35, notice it comes back with a slightly different address than the one we typed in earlier. This is due to the fact that in DNS, whilst domain names can point to IP addresses, a separate record type called PTR records exists within DNS for conversion from IP address back to domain names. PTR records are explained in more detail later in the course. In some cases, especially with larger organisations such as Google, it's possible to have more than one IP address attached to a domain name. This is known as load balancing, which will be explained in more detail later on in the course. The fundamentals of DNS have largely been the same since Windows 2000, so if you have experience with earlier versions of Windows Server, this will be an advantage when completing this course, as there have not been too many changes since that time. The main changes being the initial installation of DNS and support for IP version 6. Now that we've gone over DNS and NS Lookup, let's move on to installing DNS services. Before we can use DNS on Windows client machines, first we need to install it on the server using the Server Manager utility. This utility is designed to be a central location within Windows Server 2016 that allows you to install and configure different roles and services, including DNS. Notably, with Server Manager, you can manage multiple servers from one central console, which can often be useful when you have a large amount of servers in your organisation. In some cases, DNS is installed as part of the initial processes when setting up a new domain, as DNS, along with DHCP and some other services, forms part of the essential components needed for Active Directory, directory, as well as for name resolution in general. However, installing domains is beyond the scope of this course. To open the Server Manager utility, click on the Start button on the bottom left-hand corner of the screen and type in Server Manager in the search box. When the Server Manager option appears, click on it to continue. Once this window appears, go to Manage and then click on Add Roles and Features. When the wizard appears on screen, click Next. When the installation type screen appears, select the role-based or feature-based installation option and then click on Next. You'll then be asked to select which server you want to install DNS on. For our example, the default option of this server is fine, so we'll just click Next here. In the Server Roles dialog box, select the DNS checkbox. You'll then get a dialog box explaining what features within DNS will be installed, along with the checkbox for installing the management tools. For this example, the default options are fine, so click on Add Features and then on the Server Roles screen, click Next. On the Features screen, click on Next. You'll then see an explanation of DNS and its features. Click Next here to continue and then click on Install on the confirmation screen. DNS will then begin to install. This normally takes a few minutes, after which the completion screen will appear. Click Close here and the DNS installation is complete. Now that we've gone over installing DNS, let's move on to an overview of the DNS console. With DNS installed, let's take a look at the DNS Management Console and its many different options. Although not specified during setup, there are two different types of DNS zones. These are standard and Active Directory integrated. Standard zones are normally found when the server is not attached to a domain. These are normally used in small organizations that only have a handful of machines. In most cases, you'll be dealing with Active Directory integrated zones. If you haven't guessed already, these are found on DNS servers which are attached to an Active Directory domain and are commonly found on domain controllers, although this is by no means a hard and fast rule. To view and configure zones, open the DNS Management MMC Console. This can be opened from either within Server Manager or from Administrative Tools in the Start menu. As we've already gone over opening items from the Start menu earlier, let's open this from within Server Manager. To do this, right-click on the server name and then click on DNS Manager. This can also be opened by clicking on the Tools menu at the top and then clicking on DNS. When the DNS Manager console opens, you'll see the server you selected. Double-click on this to continue. You'll then see 4 different folders on the screen. These are as follows. Forward lookup zones. This is where mappings between domain names and IP addresses are contained, along with some other special record types which we'll go into later. Reverse lookup zones. This is where mappings between IP addresses and domains are contained. This is the opposite of a forward lookup zone, and the record types here are known as PTR or pointer records. Trust points are an advanced feature which is not commonly used and therefore beyond the scope of this course. Conditional forwarders allow incoming queries for specific domains to be redirected to other servers, usually those that hold authority status for that domain. Route hints are essentially directions for any incoming queries that don't match any configured zones or forwarders. For example, sites that are located on the internet. Route hints by default hold the IP addresses for the internet route DNS servers. Forwarders are similar to conditional forwarders, only all queries are forwarded rather than just those for specific domains. Now that we've gone over the DNS console, let's move on to creating DNS zones. To create a DNS zone, open the DNS console as explained earlier. First, we're going to create a forward lookup record. To do this, expand the server by double-clicking on it, and then right-click on Forward Lookup Zones and then click on New Zone. The New Zone wizard will then appear. Click Next to continue. You'll then be asked to select the zone type. The different types are as follows. Primary zone. This means that this will be the primary server that holds this record and that any future changes will be made here. Secondary zone. This creates a copy of a zone that exists on another server and receives updates from the primary server. Stub zone. This creates a limited copy of a zone that exists on another server and only includes some essential records such as name server, start of authority and A records. Record types are explained in more detail later on in the course. The Store the Zone in Active Directory checkbox defines whether the zone will be stored as an Active Directory integrated zone or as a standard zone. An Active Directory integrated zone will be automatically replicated to any other DNS servers connected to the domain, whereas a standard zone would need replication setting up manually via the use of a secondary zone and the appropriate zone transfer configuration. For this example, we'll be creating a primary zone, so we'll click Next. You'll then see the zone replication scope page with the following options available to all DNS servers running on domain controllers in this forest. to all DNS servers running on domain controllers in this domain. To all domain controllers in this domain, Windows 2000 compatibility, as Windows 2000 is no longer supported and very rarely, if ever, found on production networks. We don't need to worry about this option for the purposes of this course. A forest can hold one or more domain names and is often used in organizations with different sub-companies. For example, you might have a parent company and several companies that are owned by it, but separate in their own right. As our example only has one domain within one forest, both options are effectively the same. In a more complex environment, the replicate to forest option would send DNS zone information to all domains within the current forest. In this case, the default options are fine, so we'll click Next here. You'll then be asked to enter a zone name. This is the root domain name that you want to create a zone for. For this lecture, let's use exampleprimary.local. After this, you'll be asked to set the dynamic update settings for the zone. Dynamic updates allow client computers within a network to automatically update their own DNS records so that other machines or services can reach them by their hostname. Normally, for your primary domain name, this is the one on which your client machines are. This should be set to on, whilst for other domains, for example those used for website hosting, this should be set to off for security reasons. For setting up dynamic updates, the following options are available. Allow only secure dynamic updates, recommended for Active Directory. Allow both non-secure and secure dynamic updates. Do not allow dynamic updates. The only reason that non-secure updates would be used is normally for non-Microsoft DNS servers such as Bind running on Unix or Linux. For our example, the primary domain is example.local and has already been set up, so we'll select Do Not Allow Dynamic Updates here, click Next and then click Finish. The example primary.local zone should then appear on the right hand side of the DNS Manager console. Let's quickly go over what would happen if we'd selected a standard zone rather than an AD integrated zone. Assuming this was the case, the setup process will be more or less identical, except you'd be asked to specify a zone file name. If this dialog box appears, just click Next as the default options are fine here. Now that we've gone over creating a primary forward DNS zone, let's move on to creating a secondary forward DNS zone. Creating a secondary DNS zone is much like creating a primary DNS zone, although this is only necessary if using non-Active Directory integrated zones, as explained earlier. With the DNS Manager console open, right-click on Forward Lookup Zones and then click on New Zone. When the dialog box appears, click Next. On the Zone Type selection screen, select Secondary Zone and then click Next again. Note this time that there are no replication options as this is a standard zone. In the Zone Name field, type in the domain name you wish to replicate and then click on Next. On the Master Name Servers screen, you'll need to enter the IP address of the server that holds the primary DNS zone for the domain name you just entered. For our example, let's use a primary server of 10.0.0.1. Once you've done this, click Next and then click Finish. Your secondary zone is now set up. Note that before it will actually receive data, you'll need to allow zone transfers on the primary server to the secondary server on which the zone is set up. Zone transfers are covered in more detail later on. So for now, let's move on to the next part of the course, creating a primary forward stub zone. Stub zones are similar to secondary zones in that they read information from a primary source. However, there are some key differences. Secondary zones hold a complete copy of a zone as held on the primary zone and can't be replicated using AD replication, while stub zones hold only the records from the primary zone that are necessary to send an incoming query in the correct direction of the authoritative server for that zone. To create a stub zone with the DNS Server Manager console open, right-click on Forward Lookup Zones, click New Zone, and when the window appears, click Next. Select Stub Zone from the Zone Type screen and then click on Next. On the Replication screen, click on Next again. Enter the zone name that you wish to replicate from the primary server and click Next again. For this example, we're going to use a primary server of 10.0.0.1. Once you have entered this, click Next and then click Finish. The zone will then be shown on the right hand side of the screen. Unlike secondary zones, you don't need to set up zone transfers for a stub zone because it only accesses DNS record types that are publicly available. These are start of authority, name server, and glue records. A glue record is a type of a record that solely exists to allow a domain to have DNS servers that point to itself, but more on DNS record types later. Now that we've gone over creating a stub zone, let's move on to the next part of the course, creating reverse primary DNS zones. Just like forward lookup DNS zones, reverse DNS zones can also be created for primary, secondary, and stub zones. To create a primary reverse lookup zone, right-click on Reverse Lookup Zones and then click on New Zone. When the New Zone window appears, click Next. On the Zone Type window, click Primary and then click Next again. On the replication screen, click on Next again. You'll then be asked whether you want to create an IP version 4 or IP version 6 reverse lookup zone, as IP version 6 records are very rarely used in production environments. For our example, let's choose IP version 4 reverse lookup zone and then click on Next. In the network ID field, enter the range of IP addresses in use on your network. For example, if your network runs from 10.0.0.1 to 10.0.0.254, you would enter 10.0.0 in this field. Whereas if your network runs from 172.16.0.1 to 172.16.2.254, you would enter 172.16 here. For this demonstration, we're using 254 addresses in the 10 network, so we'll enter 10.0.0 in this field and then click on Next. On the dynamic update screen, as with forward primary zones, if the zone contains computers that are being assigned DHCP addresses, use the Allow Only Secure Dynamic Updates option. If the zone is being used for servers, select Do Not Allow Dynamic Updates. The Allow Both Non-Secure and Secure Dynamic Updates option is not normally used unless your environment includes non-Windows DNS servers, as explained earlier. For our example, as we're using an AD integrated reverse zone, accept the default option of Allow Only Secure Dynamic Updates, click Next and then click Finish. Your newly created zone should then appear on the right-hand side of the DNS Manager console. Had we selected not to integrate the zone with Active Directory, the setup process is identical, except that secure dynamic updates are not available with standalone reverse primary zones. Now that we've gone over reverse primary zones, let's move on to reverse secondary zones. Creating a reverse secondary DNS zone is not that different from creating a reverse primary DNS zone. To do this, right-click on Reverse Lookup Zones and then click on New Zone. When the New Zone wizard appears, click Next. On the Zone Type screen, click Secondary and then click Next again. On the next screen, select IP version 4 Reverse Lookup Zone and then click on Next. For the Network ID screen, it's the same as for a reverse primary zone, so we'll enter 10.0.0 here and then click on Next. Note that you'll need to enter the same network ID for both the primary and secondary reverse zones, as this will ensure that the setup process works correctly. As with forward secondary zones, we need to enter the IP address of the master server that holds the primary records. So we'll enter an example server here of 10.0.0.1, click Next, and then click on Finish. The newly created reverse secondary zone will then appear on screen. Note that we can't create an Active Directory secondary zone, as Active Directory doesn't use these, as it's integrated into a single system. Now that we've gone over reverse secondary DNS zones, let's move on to reverse stub zones. To create a reverse stub zone with the DNS Manager console open, right-click on Reverse Lookup Zones and then click on New Zone, and then click on Next. Note that unlike a secondary zone, it's possible to integrate a stub zone with Active Directory. Let's explore this option by keeping the AD integration checkbox ticked and clicking Next. As we've selected AD integration, you'll see the replication selection screen. As we went over this screen earlier, let's accept the default option of To all DNS servers running on domain controllers in this domain and click Next. Select IP version 4 reverse lookup zone and then click on Next again. As with the previous example, we'll use the 10.0.0 network ID and click Next. As with a secondary zone, we'll need to enter the IP address of the master server, this is the server holding the primary zone, in order to allow the DNS zone transfer. Note that unlike with secondary zones, and as mentioned earlier, stub zones don't require any specialist configuration and will work straight out of the box. For the master server, let's use an example primary server of 10.0.0.1. Click Next and then click Finish. The newly created stub zone will then appear on screen. Now that we've gone over reverse stub zones, let's move on to the next part of the course, managing DNS zones. So far, we've gone over creating different types of DNS zones, so now let's see how to manage them. To manage a primary zone, double-click on example primary.local so that the arrow to its left disappears. Then right-click on this and click on Properties. First, we have the General tab. This contains the current status, zone type and replication status, as well as the data storage location, which for this example is Active Directory. The General tab also contains the dynamic update settings, which in this case is set to secure only, the default setting for Active Directory integrated zones. Scavenging is explained in further detail later in the course, so let's go to the Start of Authority tab. First on this tab is the serial number. This number begins at 1 and increments every time a change is made, allowing the system to accurately determine which version of the zone is the most recent, should multiple copies exist on different DNS servers. Next we've got the primary server field. As you may have guessed, this field contains the fully qualified domain name or FQDN of the server that holds the primary zone information for this domain. The responsible person field contains the email address of the person primarily responsible for making changes and managing the zone. Note that @ symbols aren't used here and dots are used instead. In this example, this means that hostmaster at example.local is written down as hostmaster.example.local with the @ symbol being replaced by a dot. The refresh interval is the time in seconds that a secondary name server should wait between zone file update checks, whilst the retry interval is the time in seconds that a secondary server should wait before contacting the primary server after a previous attempt has failed. The expires after value is the amount of time that a secondary server will consider its data to be valid if it can't contact the primary server, after which time it will consider it to be invalid and stop serving client requests for that zone. The minimum time to live or TTL value is the default amount of time for the zone that a DNS client will keep a previous request cached for, providing that an explicit TTL is not set on the specific record requested. This means that the TTL for the SOA defines the TTL for only the SOA and can be overridden by a TTL set on a specific record. The Name Servers tab holds the list of all name servers that hold a copy of the zone. Note that while you can only have one server holding a primary copy of a zone, there is no limit to the number of secondary zones that you can have. Should you need to specify a Win server for any reason, you would do so here on the Wins tab, but as this is very rarely used on modern systems, let's move on to the Zone Transfers tab. The Zone Transfers tab is where you would set up zone transfer configuration. Note that for zone transfers to work correctly, you may need to make sure that any firewalls allow traffic through for the zone transfers, although firewall configuration is beyond the scope of this course. To allow zone transfers, make sure that you are managing a primary zone, which on this example we are, and then click on the Allow Zone Transfers checkbox. For security reasons, on a real-world server, do not select Allow Zone Transfers to any server unless there is a specific business case for doing so and it has been authorized by your security department. The other two zone transfer options available are only to servers listed on the Name Servers tab and only to the following servers. It's normally the case that the servers that you will be transferring the zone data to would also be name servers. Finally, the Security tab allows you to control which administrators or users have various permissions on the zone, including whether they are allowed to read zone information or make any changes. Now that we've gone over managing DNS zones, let's move on to DNS record types. There are multiple different types of DNS records, all of which perform specific functions. On this lecture, we'll go over some of the most commonly used record types, but this is by no means an exhaustive list. In the next lecture, we'll go through step by step on how to set these records up. First, we have A records. These records translate domain names into IP addresses. For example, www.google.co.uk may translate to 216.58.211.35. Although not commonly used, AAAA records perform the same functions only for IP version 6. As IP version 6 is not commonly used in internal networks, it's beyond the scope of this course. Next, we've got CNAME records. These records are aliases that point to A records. For example, you may have an A record for www.example.com and an A record for www.example.co.uk, but you don't want to have to update both whenever a change is made. Mail Exchange or MX records define the email servers attached to a domain. These are normally set externally on a service provider rather than on an internal DNS server. However, should this need to be done internally, this is how they would be set up. As you can see here, we've got the primary and secondary MX records with a number to the left of the mail server name on each record. This number is a priority value and determines which server's mail delivery is attempted to and in what order. A lower number here means a higher priority. A higher number here means a lower priority. And an equal number on more than one record results in load balancing between those servers. As explained earlier, the start of authority or SOA record has information such as the zone serial number and TTL values. This record type can only exist once per domain, as amongst other things, a domain can only have one serial number. Finally, there's pointer or PTR records. These are the reverse of A records and allow translation from IP addresses back to domain names, and determine what domain name appears in NSLOOKUP when you type an IP address in the search box. Now that we've gone over DNS record types, let's move on to the practical side of things and learn how to set these records up. With the DNS Manager console open, creating a DNS record is fairly simple. To do this, right-click on the zone where you want the record to go and select a record type from the list. For A records, right-click on the zone and click on New Host. You'll then be asked to enter the name and IP address for the new record. The Create Associated Pointer PTR record checkbox allows you to create a reverse record at the same time. This can be invaluable if you have a large number of records to create. The Allow Any Authenticated User to Update DNS Records with the Same Owner Name checkbox allows any computer with the same name as the record to update its own IP address in DNS whenever it changes. Once you've entered all the details for the new record, click OK and the record will be displayed on screen. For CNAME records, the options are quite similar. As explained earlier, a CNAME record is an alias that points at an existing A record. For this record type, you need to enter the alias name and the fully qualified domain name or FQDN of the A record that you want to point it to. The Allow Any Authenticated User to Update All DNS Records with the Same Name option is the same as the equivalent option for A records in that it allows computers to automatically update their own IP details in DNS whenever they change. For MX records, as explained on the screen itself, only the FQDN and priority fields are needed here. An SOA record is created at the time of zone creation and therefore cannot be manually created again. Finally, to create a new PTR record, make sure you're in the Reverse Lookup Zones folder, right-click on the existing zone where you want the record to go, and then click on New Pointer PTR. To create this type of record, you'll be asked to enter the hostname and IP address it needs to be mapped to. The Authenticated User Update checkbox has the same function for computer updates as the other record types. To manage a DNS record once it's been created, right-click on the record in question and click on Properties. The options are more or less the same as for all records in that they allow you to change the details specified during creation, with the Security Settings tab controlling the permissions that define what administrators can and can't do in regards to reading and changing the record. Now that we've gone over creating and managing DNS records, let's move on to root hints. Root hints are pointers that a DNS server can use if it is unable to give an answer to a DNS query from a client computer. These are used for DNS servers that also need to provide DNS resolution for internet-based sites. By default, root hints are set up on Windows DNS servers. To access the root hint, right-click on the name of the DNS server and click on Properties. There are some other advanced options / tabs here, but these are beyond the scope of this course. There are 13 root servers from a.rootservers.net all the way to m.rootservers.net. These servers are located at different points worldwide and ensure that DNS resolution will always be available should any one or more servers fail. They are the master reference point for all internet DNS queries, much in the same way that atomic clocks are considered to be the primary source of time. These servers do not normally need to be changed. The only reason you might do this is if the server is dedicated to internal queries only, in which case you would remove all of the servers and then click OK. Now that we've gone over root hints, let's move on to load balancing and round robin. So far, we've gone over the creation of different types of DNS records, but what if you want the same domain name or subdomain to point to multiple IP addresses in order to load balance traffic, for example, between multiple web servers? To do this, simply create an A record in the same manner as before, but then create a second record and use a different IP address, while keeping the same domain or subdomain as you used in the first A record. This can be repeated as many times as needed for the amount of servers that you want to load balance traffic to. Although load balancing can be an advantage, there is also the flip side in that if one of your servers goes down, some attempts to reach it by clients will fail. For example, if you have two records pointing at a web server and one of these servers goes down, 50% of user traffic will fail unless somebody manually removes the DNS record relating to that server or the faulty server comes back up. This is why in a real-world environment, advanced options such as failover clustering are normally used rather than round-robin DNS, although it is important as an administrator that you know and understand how round-robin works, as this is used in some situations. Now that we've gone over load balancing, let's move on to the final part of the course, DNS scavenging. DNS scavenging is one of the most important things to know and understand when using DNS. Scavenging is an automated process within DNS that purges old records after a set amount of time, so that the DNS database is as up to date as possible. For example, your organization may have a large number of pool laptops that are only switched on a few times a month, but that automatically update DNS when they get a new IP address. Over time, IP allocations change between machines. In theory, whenever a PC shuts down, it should delete its records from DNS as part of its shutdown process. But this isn't always the case, especially if a machine is forced to shut down, for example in the case of a power failure. This can result in multiple PC names resolving to one IP address and vice versa, which can cause resolution problems for programs such as antivirus management, which relies on these records being accurate. This is where DNS scavenging comes in, as it can delete the out-of-date records depending on their expiry date. To set up DNS scavenging, right-click on the server in the DNS Manager console and click on Set Aging/Scavenging for all zones. On the Server Aging/Scavenging Properties dialog box, we've got the No Refresh Interval and the Refresh Interval options. The No Refresh Interval option is the time between the most recent refresh of a record timestamp and the moment when the timestamp may be refreshed again. The Refresh Interval is the time between the earliest moment when a record timestamp can be refreshed and the earliest moment when the record can be scavenged. The refresh interval must be longer than the maximum record refresh time. This process can also be run manually by an administrator by right-clicking on the server in the DNS Manager console and then clicking on Scavenge Stale Resource Records, clicking Yes when prompted to confirm that you wish to proceed. There is an option for static records designed for servers so that they can be exempted from this process. However, in a real-world environment, you need to be extremely careful about enabling DNS scavenging, as this is done at a global level and can have serious effects on your domain. Although in theory, servers have static entries and clients have entries with expiry dates, it's often the case that servers have auto-registered themselves rather than being set up with static records manually by an administrator. In other words, double and triple check with your colleagues before enabling DNS scavenging, especially on a server in a production environment, as this can have the unintended effect of deleting all server A records on your server and causing serious problems to your organization's network, as well as possibly your career, so definitely one to watch out for. You've now reached the end of the course. I hope you found it useful, and if you have any questions, please feel free to ask. I'm John Courtney, and thanks for watching.